Hello everybody, welcome back to the Creating Datasets series. In this second video we're going to look at understanding datasets and examining your own data before you begin to actually create the dataset. In the previous video we looked at the background to datasets, and here we're going to look at preparing for creating your data set. The question is, why should I prepare? Why shouldn't I just go for it? Well, the reason we think first is that data can be complex. A single data set can contain many different types of data, and you have to make all sorts of choices to do with what you're going to put in, what you're not going to put in, how you put it in. And so because data is complex, it really helps if you can think about it before you start. And planning helps. Planning helps with everything. If you've got all your bricks in a row, it helps you to build your house. And so I really encourage you to think about your data and to plan before you start putting it into a data set. So let's look at data in brief. Think about what data will be in your data set and what it might look like. First of all, the amount. So to start with, you only put the data in the data set that is directly relevant to the publication. As we said in the previous video, background data and supplementary data. The things that are relevant that will make your publication more interesting and more grounded in reality, so to speak. And then, so when we think about the amounts for articles, often a single, the article is always on a single concise subject, and often one file will be enough, one file containing all the different aspects of your data set. But for things like theses and reports, obviously those publications cover a much broader range of research, and so frequently, probably always, you need several files, often quite a number, but they can all go into a single data set and into a single item. But you do need to think about your data. If you look at the picture on the right here, think about your data is often, when you start off, is quite scattered, and you need to organize it into some kind of logical sequence. So the second thing you need to think about is, are there restrictions on your data? So if all your data belongs to SEBA, then you don't need to cite anyone else. But if your data came, if for example you're doing a review and you've pulled data in from other sources, or if you're working with somebody in another unit, then you need to acknowledge that. And then the second thing is it open source? May you use it without permission? And then ask yourself, is it secret? For example, some of our research is done with industrial partners, and they don't want their information all over the internet. So you need to check whether you may put it out there, and if you may not, some of your files may need to be restricted access. And then lastly, must someone be protected? So anything that includes human subjects, for example, if you do a survey, you need to make sure that you have permission, their permission to put that information out, and you also need to make sure you can de-identify it so that nobody will know who the original participants are. And that can be quite an interesting exercise, both statistical and sort of logical. So you need to think about whether your data can just be put out there or whether there are some kind of restrictions on it. The third thing we need to think about with our data is how raw are we going to go? So your data consists of multiple levels of data. There's raw data, the stuff that you actually got out of the instrument, and then sometimes that data has to be worked up in order to be meaningful. So you might take an OD, but what you're actually looking for is the concentration. So you take an OD and you use a standard a standard graph to give yourself the concentration. So the concentrations are the actual thing you're going to use, but your raw data comes in another form. And so you have to decide how raw you're going to go. That is something that needs to be thought through quite carefully. And obviously, you definitely don't want to cook your data, which for those who aren't English speakers means that cooked data means when you've taken data and you've made it, you've changed it so that it says something that it didn't originally say. So the opposite of raw data is not cooked data. It's calculated data or worked data or applied data. But you definitely must always obviously be careful that it harmonizes with the original raw data. So having thought about different aspects of your data, you need to assess it and look at the types of data that you're going to need in your data set. We talked in the previous video about information data. So the first type of data is your actual data that you collected, and think about how it comes. It may be text in the form of tables or lists or descriptions. It may be numbers in the form of tables again, or calculations, maybe formulae, graphs, and charts. It may be images, photographs, photographs of your rig, or photographs from the microscope, or images from one of the other more sort of intense forms of image taking. It may be diagrams, it may be flow sheets. And then, of course, when we've done simulations, it may be code and models. So think about what kind of information you've got in your basic actual data, the stuff that you created or collected. And then there's types of explanation data. In the previous video, we talked about the kind of data that you need to make your data usable and understandable. So here, if you've done experiments, you would need to include things like an experimental plan, stuff about your equipment, what models did you use for your assays, what conditions and methods did you use, what was your rig like, and so on. And then for your data analysis, you're going to need to include things like details of your calculations, statistical methods, formulae, and if they're not known, formulae, where you got them, and data analysis criteria if you've done a criterion-based selection. And then your selection criteria for example, if you chose people to interview, how did you choose them? And then comments and so on in code which make it understandable. So think about what it is that you're going to need extra to the actual numbers or words that you're going to that form the basic data. What is it that you're going to need to show people exactly what happened, or to enable them to redo what you did? So having thought about what our data is like, how much and so on, having thought about what type of information data, what type of explanation data we have, we need to consider the format. How best can we present our data so that it's fully usable and understandable by others? So here the key word is interoperable. We want people to be able to download a file and use it, work with it. So the sort of gold of open data is, of open access, is unlocked open formats. And the sort of second prize is widely accessible formats and not locked again when we save them, when we upload them. So, and then also we obviously have to ask, is this file size for this format good for what we're doing? So in CIBA, what we mostly use in our work is the Microsoft Office suite of programs, and then we use photos, mostly these days taken with the cell phone, and code. Obviously we use different simulation packages as well as more basic direct code, and then we use microscopes and so on. So think about what format your data is in already, and what format you're going to put it in your data set. Now I have a suggestion, which is our sort of CIBA suggested format at this point, which is that for most things we use a Microsoft Excel workbook, because all our Microsoft Office formats can be pasted into a workbook and they keep their functionality. So for example, if we've done a flow sheet in Microsoft PowerPoint, we can paste it into Microsoft Office, Microsoft Excel, and it will keep all its formatting, all its maneuverability, and the person who downloads it can then just work with it direct. So we don't lose any functionality. So that is our suggested format, unless you have a particular reason to use another format. And then think about your structure. How many single subject units will work? So each unit should be a single file. And as we said before, mostly in articles or conference papers, a single file will be enough. But in the bigger publication formats, then we'll need multiple files. But we need to think about how to divide that data up. What units are going to be best? So, for example, in a thesis, you might follow your chapter divisions, or you might take a file which has one section out of each chapter, and then another file with the next section out of each chapter, depending on your data, on the format of your thesis. And then obviously, so we need to work out how many workbooks we need, how many units we need, but then within each unit, what is going to be needed in that workbook or in that unit. And we can, there are some suggestions for that, which we'll look at in another, in the next video. But there's also a CEBA generic experimental template, which will give you ideas of how your workbooks might be divided. So that's a little bit of background in the first video, and a little look at some of ideas for thinking through your data and for getting yourself ready to go for it and make your data set. And next up, video number 3 is looking at that information data that we've talked about already. So I just want to acknowledge how much I've learned from UCT research and the Digital Library Services people. And when you ask me questions and I don't know the answer, I go back to them and ask them. And obviously, if I'm not available at any time, you're also welcome to ask them direct.